Okay, so here we go. Like I said, how do you get 3 squared? We know that 3 squared is 9, but how do you get that? 3 times 3, right? So then x squared is the same thing as x times x. So then x cubed is the same thing as x times x times x. So 3 squared is 3 times 3, x squared is x times x, and x cubed is x times x times x. So let's use those from above to figure out these rules, okay? The first example is x squared times x cubed. Well, we know from above that x squared is x times x. So we can do xx, and we know that x cubed is xxx. Okay, so if we take this and we say x squared times x cubed gives us x to the what? How many x's are there? 5. So this is x to the 5th. So what can you say as a rule we would do with the exponents? We added them, right? So a to the m times a to the n would be a to the m plus n. So if you have 2 bases that are the same, then you can add the exponents. The next example has x squared cubed, but we know that x squared is xx, right? And since it's cubed, how many times are we going to write that out? 3 times. So we're going to have xx, 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 which you're right, does end up giving us 6 x's, right? So what rule would we use for there? We're not adding because 2 plus 3 is not 6. What would we have to do with those exponents as a rule? You would multiply. So a to the mn. So here you multiply. Here you add the exponents. So verbally, how would we describe the difference between these? How do you know when to use each of those 2 rules? Visually, how do the problems look different? One does have parentheses and the other doesn't. Okay, but we can't use that rule on its own because we're going to have some problems that have parentheses just because of negatives. But how else do they look different?
One has 2 bottom bases.
That's right. That's exactly it. This one has 2 bases, so we add. This one only has 1 base. These guys are really, really close to each other, and so we're gonna multiply those. Okay, so that's how you can visually kind of tell which rule to use. All right. So let's look at this last one, 2x squared to the 4th. Okay, so we have 2xx to the 4th because we know that x squared is xx. How many times are we going to write 2xx out? 4 times. So if we look at the numbers, just the 2, remember this is all multiplication. We're multiplying all the way across. So what we have is 2 times 2, which is 4, times 2 is 8, times 2 is 16. And then how many x's do we have? 8, right? So what happened here? Did the exponent, did this 4 go to just the x? No, it went on to the 2 also, right? So this is because you get 2 to the 4th and x squared to the 4th. So the 4 essentially distributes to each of those terms. Now, distribute is not the correct terminology. You will not see that in your book. Okay, visually that's what it reminds us of though, is distributing. Okay, but this is actually raising to the power. So you're going to raise each piece to the power that is outside the parentheses. Okay, so AB to the M becomes A to the M, B to the M. Okay, so before we begin the next examples, I want you to look at 1 through 4 and just write add or multiply. So you're just determining which rule to use, add or multiply. So I'm going to keep the bases the same. I'm going to add the exponents. Keep the base the same. Multiply the exponents. Keep the base the same, which is -5. Now if a negative starts in parentheses, it stays in parentheses. But what are we adding? 19 plus what? 1. That's right. There's an implied 1 right here because there's 1 -5. So if we add those together, we get 20. Keep the base the same. Multiply. Okay, so 5 through 8, what rule are we using? The third one, the distributing, and when you distribute, you also multiply exponents. So you are multiplying the exponents, but you're also distributing it to every single piece of it, okay? So looking at number 5, what I would do before I begin is I would put exponents on anything that doesn't have an exponent. So the x and the y each have an exponent of 1. So when you distribute in the 4, you multiply those exponents, and 1 times 4 is 4. So you just have x to the 4th, y to the 4th. Number 6 does not have an exponent on the 5 or the x, so put a 1 on it. I don't know why those just moved. We're going to distribute in. Now notice when I say distribute in, I'm distributing inside the parentheses. That negative is not touched, okay, because it's outside of the parentheses. So we're just going to bring that down, and we're going to work inside. So we're going to have 5 squared and x squared. Again, we have not touched the negative, so we can just bring that down. And then what is 5 squared? 25, because it's 5 times 5, right? So we get 25 x squared. Now number 7 has 2 sets of parentheses or brackets, whatever you want to call them, okay? But the only reason why they have that is because of the negative, okay? So if a negative starts in parentheses, it stays in parentheses. And all they're doing is asking us to work with those 2 exponents. What should we do with those, add or multiply? Multiply. There's only 1 base, right? So we're going to multiply those so we get to the 6th power. Now that's going to be a really large number. You can multiply that out, or you can type it in your calculator, but you could also leave it like that, okay? Because those are very large numbers. I don't need you to actually evaluate that. Okay, now number 8 has a box in it. This is strictly a typo, not necessarily a typo, it's a compatibility issue between different versions of Microsoft Word. So all of these boxes are just dots for multiplication. It's not new symbols or anything like that. So for number 8, there's an exponent of 1 on 5 and 1 on 19, and we can distribute in. We have 15 to the 3rd times 19 to the 3rd. Or, please excuse my dear Aunt Sally says you could do parentheses first. And in all the other problems that we've done so far, there's nothing we could do within the parentheses, but in this problem we can. We can do 15 times 19. If we do 15 times 19, I think you get 285. Will somebody verify that for me? To the 3rd. So for 9, 10, 11, and 12, it has kind of a combination of rules here. So number 9, what would we do? Add or multiply? Add, because there's more than 1 base. Okay? So x to the 11th, because 5 plus 0 plus 6 is 11. Number 10, this is much like number 8. You can either distribute in, or these are even easier numbers to work with. I would simplify inside the parentheses first. Negative 4 times 2 is negative 8. Again, if the negative starts in parentheses, it stays in parentheses to the 5th. Number 11. That 10 does not have an exponent on it, so I'd put a 1 on it. Distribute the 2. Now when you distribute the 2, you're not doing negative 10 times 2. You're multiplying the exponents. So the base stays the same, the negative 10 stays the same, but if it starts in parentheses, it stays in parentheses. So negative 10 squared, because 1 times 2 is 2. X to the 3 times 2 is 6. And then there's nothing that we can do with that negative x to the 7th yet. The only reason why it's in parentheses is because of the negative. So what is negative 10 squared? I hear 100 and I hear negative 100. Which one? If you have negative 10 squared, this is really negative 10 times negative 10, right? So that gives you 100. That is different from number 6. Number 6, the negative was outside of the parentheses, so it stayed with us during our whole problem. It just stayed out front. It was not touched by the square. Okay? We only worked with the 5. But here the negative is part of the square. Okay, so then we have x to the 6th times negative x to the 7th. And we know that a positive times a negative is a negative. X to the what? Add or multiply? 1 base or 2? 2 bases, so that means that we add. And we really, if something's going to be negative, we want to write the negative out front, okay? So we know that a positive 100 times a negative x to the 13th, so positive times a negative is a negative. That's just a little bit better to write it that way. Okay, now number 12. How does number 12 look different from every single problem on this page? Huh? What does it have that the other ones don't? The subtraction sign, right? This subtraction sign, or addition for that matter, if you have adding or subtracting, you may not distribute. Okay? This, if you have x minus 4 squared, does not equal this. It does not square both pieces. Okay? But what this is asking us to do is keep the x minus 4 as it is. And then it's asking us to just work with the exponents. So what are we going to do with those? Add or multiply? Multiply. And that's all we could do. This is not that. You have to leave it just like this. Questions?